So in this question here, we're given the scenario where we've got a wooden beam used to support a wall built on a horizontal ground, as shown in the diagram there. Edge of the beam is 8 meters long, C is at the foot of the wall. We're then given the dimensions from A to C and B to C. What we're then asked to do is determine whether the wall is perpendicular to the ground and justify your answer. Now, the key thing there is justify your answer. You can't just write yes or no. We have to say why. Now, this one here is asking us whether it's perpendicular. Now, remember, perpendicular means at a right angle to. So if we can prove something's at a right angle, what that means is it's perpendicular. In order to prove something's a right angle, what we're able to use is Pythagoras. This question is all built around the converse of Pythagoras' theorem. Because if we can show Pythagoras holds, the triangle is right angled, which means it's perpendicular to the ground. So that's what we have to work with. So in order to do this, what we're going to do is imagine we set it up as just a right angled triangle here. 8, 7, and 4. And let's begin by assuming it's a right angled triangle. So what that then means is Pythagoras' theorem holds. So if we assume that it's right angled, then a squared equals b squared plus c squared. That will be true, so we'll get the same values on both sides. So let's have a look at that, because if that holds, then we have it right. So a is always the hypotenuse, and the b and c are the two shorter sides. So what it wants us to do is first look at 8 squared, and then look at 7 squared plus 4 squared. Now 8 squared, 8 8s are 64. 7 squared plus 4 squared, well 7 squared is 49. 4 squared is 16. So 49 plus 16 gives me 65. So actually in this case, a squared does not equal b squared plus c squared. So Pythagoras' theorem doesn't hold. Because Pythagoras' theorem doesn't hold, what that means is the triangle is not right angled. Now what we have to do is, we've proven it mathematically, we have to explain what this means. We have to be able to get our explanation statement right so that we're ensuring we're telling them what technique we're using and why our solution indicates it is not a right angled triangle. So if we use a statement such as this that says since 8 squared does not equal 7 squared plus 4 squared, by the converse of Pythagoras, the triangle is not right angled, this is the kind of statement we are after. Because what we're telling them is the calculation we've done, the technique we're using, the converse of Pythagoras, and then we're interpreting this and saying what this means, that it's not a right angled triangle. So because it's not a right angled triangle, it's not perpendicular. You must include a statement that looks something like this, particularly if you actually end up proving that it is a right angled triangle. We have to make sure that we say the technique. So this phrase here, the converse of Pythagoras, is a vital phrase to learn and to use when it comes to something like this. It's vital that we're able to use that as part of our explanation so that we can tell people, this is how I've done it, this is what it means. So for this technique here, this first step here of knowing that I've got to do 8 squared and knowing that I've got to do 7 squared plus 4 squared, that's your first mark. Your second mark comes from getting the two values of them. Your third mark comes from the statement about them not being equal to each other, so interpreting that, and then the fourth mark comes from the rest of the interpretation. What does this mean when 8 squared isn't 7 squared plus 4 squared? How does that come into play, and how does that play into the question and our solution and our communication of the answer? We have to bear that in mind. So questions like this, where it's asking you about proving triangles are right angled and working with them, this is what you should spring to mind instantly. You should start to think about Pythagoras, you should start to think about using the converse of it, and assuming that if Pythagoras holds, the triangle is right angled, so let's prove either way if it does or does not hold. If that's the case, and we follow those steps, we'll actually find it works to do okay, and it ends up being fairly straightforward, so easy peasy, lemon squeezy.